3. Yeah, very good. All right, next one is a true or false. If you just give me some patience here. It's probably going to take me longer to snip in than for you to answer, but that is, so they're asking here if the correct way to solve this is to subtract 3 from both sides of the equation. So you have to think about what is going on with the 3. What's the math operation between the 3 and the x?
Multiplying?
Yes. So you undo multiplication with division and addition
Okay,
with,
so then it would be false then.
it would be false, yeah. Sometimes you almost just need to solve it, and say, okay, how do I get the answer? And then that tells you how to answer this, because you now have something to go off of. Okay. Back to the chat here. It's one of the things I just don't like about Zoom, but nothing I can do about it. All right. So the next one I have is question 9. Sorry that it's out of order. All right, solve the equation below. So your focus has to be on the side with the variable. This is the one thing I guess I don't know why this doesn't get made more clear in the classroom, but you just look at the side with the variable. You don't care about what's going on the other side. You ask yourself, what do you need to do to undo this subtraction by 9? And you would say,
add
9. So this is 29. Now, what I can't tell is if you need to write y equals 29 or just put the value of 29 in the box there.
I think you did. I put it in the box unless you changed it a bit.
Okay. This looks like stuff you would see going into algebra 1, not for a geometry student that's already.
Yeah, I don't know why she put this. I mean, she's not even here, so I can't even ask.
Yeah. Sometimes you don't want the answer to these questions. So again, you look at the side with the variable, you're going to subtract 3 from both sides. So W
12
equals 12. Good. All right. So the next one, 11 here, has a little bit of a more challenging thing to it here. I'm going to rewrite it. And this will help you for standardized test prep. There's a couple of things you can do. I know you can just get the answer, but I want you to see a few things that you can do. You can cancel horizontally as well as vertically. So what I mean by that, and it works in a problem where you have bigger numbers, but you can divide both of these by 5. Okay, and that's something that will make this faster. You can also swap positions diagonally.
Make it 5 over 20 and 1 over x.
But you'd only want to swap one position. So you'd want to swap the x and the 5.
Oh.
Why is that? Why do you think we would do that?
Because you want x to just be x.
Yes. Okay, so these are some things that will speed up your calculations. Like, because we saw some problems earlier where it was like sine 35 degrees equals 12 over x. And if you remember that you can swap diagonally, you can quickly get to the answer without having to rewrite a bunch of stuff.
Okay.
These are things that will save you a ton of time on those standardized tests that you probably get tired of seeing. All right, back to 4 here. All right. Go ahead and read the question here to yourself. Again, I'll say focus on the side with the variable and decide how to undo that.
Add 3?
Yes.
Okay. So x would be 15 then.
X would be 15. All right, question 5, kind of the same deal here. You look at the side with the variable. So just the side with the variable. What's the 2 doing to the x?
Dividing.
Yes. How do you undo division?
So then I'd multiply it then.
Yes. So this
X would
equation,
equal 30 then.
yes. So this equation can be written a couple ways. It could be written as 1/2 times x equals 15. X over 2 equals 15. There's a couple of ways for it to be written exactly the same way. You could even go to a decimal, I suppose. You have to be comfortable with any of these notations because they're all the same.
Okay.
I have a calculus student right now that's just constantly asking me about notation and led me to think maybe the notation isn't being clearly described in the classroom. So I don't know. All right, and number 12, go ahead and try this one on your own, please.
-6, x equals -6.
Yes. All right, so back to question 6. What would you do to solve the equation below? Focus on the side with
subtract 4.
yes. Very good. Number 7 is really similar.
Okay. Divide by 5.
Yes.
Okay.
They're all A.
Oh no.
Right,
Hopefully she doesn't do that tomorrow. Be easy.
Probably not. It's rare when you get a bunch of things the same. All right, for some reason I got a weird go. All right, I got 13 next. That's the next problem I'm seeing. You'll have to tell me if we've missed a bunch. I'll go back and look, or you can tell them. So this one you solve by dividing. You divide both sides by the number that's in front of y. Doesn't matter what it is, just whatever's in front of y.
So y would equal 3 then?
Yes. All right, 14. 14 is just a tiny bit of like explanation to just, because there's a few ways to do this. You could look at this as -a over 4 equals 9. Right now, the negative's out in front. You can look at it as -1/4 times a equals 9. That's okay. You could also look at it as anything that I've written here where you put 9 over a fraction bar over 1, fraction bar over 1, and you have to decide which one you like, which one appeals to you. I can give you my preference, but it's really going to come down to what you like, how you see it. Do you see it as 1 step or 2 steps to solve this?
I see it as just I multiply 9 by 4 and just make it a negative.
Okay, so here's what I heard, and that's kind of the 2 step. That's I'm going to multiply both sides by 4. Now, if you change it real quick to a negative, then it's 1 step.
Yeah.
But that becomes -a equals 36. You still have to get a by itself. This negative cannot
And
be.
then I turn that 36 into a negative and a into a positive.
Yes. So if you want to do it in 1 step, you might change it to a -4 that you multiply both sides by. Kind of up to you. There's not a wrong answer. It's just, it's how do you see it? How do you kind of envision working through it?
Okay.
All right. So I don't have 15. I'm sure we missed some. Can you either give them to me verbally or resend the ones that we didn't get to?
Which one are you missing?
I don't know. You have to tell me which ones you didn't have. I know 15 for sure didn't come through because I'm on the last picture and
there were only 15 problems. So
right. Are there any that we did not do that you want us to do?
No. 15 is -25x equals -25, and x will just equal 1 because that's
correct.
kind of easy.
Got it. Okay. We got some time left. Do you want us to do some SAT prep? Do you want us to do more problems like this? What would be best to help you
Can we do more problems like this? Because we'll be working through problems like this all week.
Sure. I got to make these more difficult though. These are kind of ridiculous how simple they are for you, because you're a good math student. You have the mind to be challenged here. Let me do some more fractional stuff, because I think that'll be more, I think that would be more of the challenge for you. So let me quickly come up with some problems here and see if see if I can find it. Let me try this. Let's say it's 2/3 x equals -15. Could you try solving that, please?
Divide by 3, 5, 10. 2/3 of x. By 2. Whoa. And then add 7, -27.5.
Yes, so let me ask you, how did you proceed? Tell me what you did first.
I knew 15 was 2/3, so I did 15 divided by 2.
Okay,
Multiply it by 3 and then turn that into a negative.
All right, so you generally, here's what you generally don't ever want to do. You don't divide by fractions. And you didn't do anything wrong. It's just that it's weird. If you divide by 2/3 and you divide by 2/3, it's kind of weird. Like it doesn't work. It works, but it's like, what do I do from here? Not like, so that's thing number one. So here's how I wanted you to solve it. And it really depends on how you look at this. One way to look at it is 2x/3 equals -15. And then you can multiply 3 and -15. Have you seen that before?
Yes, I have.
So that would be 2x equals -45. And then you could divide both sides by 2. And x would be -45/2. It is -22.5, but typically the fractions are okay.
Okay.
That's one way to do it. The other way, and this is the way I want you to do it, because this is what good math students do, is they multiply by the reciprocal. On the left, it cancels. On the right, you get -45 divided by 2. Notice it's the same value.
Okay, that makes sense.
Okay, so let's try another one here. -3/4 x equals 30.
Okay. Well, I'll just do it how you told me. Negative. So 30/1. 3/4. X is -40.
X is -40?
Yep.
Okay. Did you multiply both sides by the reciprocal?
Yes.
Now on the right side here, did you multiply or divide first?
I divided first.
You did. That's very good. That is the better way to do it, because when you divide, pre-reduce, things get better. It ends up being -40. Good. Okay, let's look at another type of problem you might see. Let's say it's -x/0.5 equals 12.
Okay.
Any idea how to maybe work on this?
That'd be 24. -24.
It is -24. No. I'll let you talk me into that. It is not negative 24. Try again.
Well, it's asking it to be divided by 0.5, right?
Which is not the same as 2.
Oh. Okay. Hmm. Oh, it'd be -6.
Yes. Yes. So a couple ways to do this. You could envision it as 1/2 down here on the bottom, and you could multiply diagonally, 1/2 and 12. Not sure how you saw this, but there's like a ton of ways to look at this. You could similarly say, if it's 1/1/2, that becomes 2. So another way to look at this is it's really -2x equals 12.
Mhm.
How did you do it, or what did you think through to work through this?
Well, I remembered that 0.5 is basically just times 2 instead. So I was like, oh, okay. So I just had to do 12 divided by half.
Got it. Got it. Okay. Be careful though. What you just said here, 12 divided by a half, is actually 12 times 2, because you never divide by a fraction, you always multiply by the reciprocal.
Okay. Okay.
All right. So let's try another one here. Let's say it's x over 0.8 equals -20.
X over 0.8 equals 20.
-20, yeah. And your choices are any of the above that I've talked about. You can convert that 0.8 to a fraction. You can multiply diagonally.
It would be -16.
Yes, x is -16. Good. Okay, now we're doing a lot of problems where the variable's in the top. Not always going to be in the top. Okay, let's go like 5 over x equals 3 over 2. So in this problem, you're going to have to do a couple of things here. One option is to always swap positions, not to multiply, but to swap.
Okay.
The reason you might do that is because when x is in the top, you can more easily solve for it by undoing whatever is here. So notice you can multiply both sides by 2. And so x is going to be 10 divided by 3.
Okay.
You remember the other thing I talked about in terms of what you can do and for simplifying? I said you can simplify horizontally or vertically.
Yeah.
Okay, so let's look at some problems like that. Let's say it's 160 over x equals 32 over 3. So before you swap, you might want to consider a horizontal.
160 over 32.
Well, what goes into both? Think of it as like you're going to divide both by some number that goes
Okay, so I'll do 160 divided by 32, which is 5. 5 goes into both of them.
Okay, so that makes it a whole lot better. It becomes 5 over x equals 1 over 3.
Yeah.
Now can you solve it?
Yeah, 15. X equals 15.
X does equal 15. Good. And you might not notice that, from the start. So you can also, again, go like, let's pick some, let's go 40 over 25 equals 16 over x.
Okay.
So here you can actually pre-reduce this way and this way before you might start multiplying.
All right, so I do 40 over 20. Okay, I can do 40 divided by 16. 5. And then So B 25. X equals 10.
Okay. So did you do 40 and 16 first?
Yeah.
Okay, so like 8 goes into both, so you can reduce that to a 2 and a 5.
Yep.
And then 5 and 5, so that's 1 and 5. And
Mhm.
then you can swap positions and multiply. So yes, X equals 10. Very good. All right, let me throw up just one other problem that we didn't talk about, but maybe you can do without any more discussion. Just throw this one in
Okay.
front of you here.
X plus 2 equals 3. Why know that means equals 6 then. Okay. X equals 5.
X equals 5. Good. All right. Good job. Any questions, thoughts from what we did today?
Nope.
All
Nope.
right.
It
Well, great.
was pretty straightforward.
Yeah, good lesson today.